Welcome to the 29th Annual Exhibit of Hydrogen and Fuel Cell Technologies at the Hanover Fair. At the Technical Forum, we do the deep dive into the fundamentals of the industry and the details. They're what you get here. Up next on stage, we'll be talking with, or Veronika Schelling will be talking about how to maximize the uptime for large capacity hydrogen compressors. She is the HME Leader at Burckhardt Compression. Welcome, Veronika Schelling.
Thank you very much. Welcome, everybody. There are hydrogen production plants, there are hydrogen liquefaction plants, there are hydrogen fuel stations, and they all have one thing in common. We want them to be up and running for the best possible performance and profitability of the plant. One key equipment which is determining the uptime of the total system is the compressor, and that's what we are experts in. My name is Veronika Schelling, and I'm the Hydrogen, Mobility and Energy Leader at Burckhardt Compression in Switzerland. And today I will tell you how to maximize the uptime of such a large capacity hydrogen compressor with best-in-class compression technology, with smart machine monitoring systems, and with a globally proven maintenance concept. Now, where are all these compressors being used in the hydrogen value chain? Actually, if we start from left to right, you can see that already where the hydrogen is being produced, typically green hydrogen in an electrolyzer, you need to have a first compression step. The point is, in order to transport the hydrogen in a more efficient way, typically it emerges the electrolyzer at a pressure of between 1 and 40 bar gauge. So to have it in a good state for transport, you either compress it using a compressor, or you change the state of hydrogen by liquefying it, converting it to ammonia or another syn fuel for further transportation. So then if we move to the next stage, transport and distribution, there are different ways. For the liquid hydrogen or also ammonia syn fuels, you can use ships, bunker ships, you can use trailers with liquid hydrogen tanks, but also using gaseous hydrogen, you can fill it in tube bundles and transport it with a trailer. One more efficient way also to transport the gaseous hydrogen is using the pipeline system, which especially in Europe is a very nearby solution how to distribute the hydrogen within the different regions. So whatever kind of transport and distribution system you choose, there will be a compression stage required for it. Then we achieve the last step, so it's the final use of the hydrogen. Can be at a fuel station, for example, which again requires a compression step, or it can also be still one main consumer of the hydrogen within the industry. So it can be like energy-intense processes like steel industry, but also the kind of, let's say, conventional hydrogen consumers in the industry, like fertilizer production or aniline plants, which will replace more and more the gray with green hydrogen. Now, what kind of compressors do we use for these processes? I will start on the small end of the scale, so that's the diaphragm compressor unit, which we use typically for fuel stations, achieving higher pressures but limited in capacity. Now, if we want to go for higher capacities, we have these oil-free vertical piston compressors. And one typical use case is trailer filling. This one picture is a CS compressor, which is used for a 10 megawatt electrolyzer capacity equivalent. Then if we go to different applications like pipeline injection or liquefaction, typically we have a moderate pressure level up to maximum 100 to 200 bars, and we use horizontal compressors. Typically lower hydrogen pressures require very large absolute volume flow, so we also have piston diameters over 1 meter. And these kind of horizontal piston compressors are used for such applications. They can be of really large size, up to 8 cranks, and that's one of the compressors which I want to base on the example today. So I would like to show you what 3 success factors you need to comply with to maximize the performance of your system. The first one is really the technology. We have the leading oil-free compression technology in-house. Why do I say leading? What eventually our experience shows, what eventually is determining the lifetime of the runtime of the compressor is not the tons of steel around it, it's the internals of the compressor, the wear parts. Typically it's the rings or the valves that will fail most often as a wear part. So we focus a lot of attention, of R&D investment on these kind of specific parts, like the rings. So it's the sealing rings, the packings, but also the piston rings, which I marked, which are essential for the lifetime, the uptime of the compressor. We design the rings ourselves, but also the materials of the rings we do ourselves. The second is really the machine monitoring. It is essential during operation that we know the condition of the compressor. We monitor it well, and we can also predict where and which part of the compressor is in a critical state or needs replacement in a due time. And the last point is evenly important. So one is to collect the data, to use machine learning, but the second step is also how to interpret these data. And this is based a lot on experience of our field service engineers. They have decades of experience in how to maintain and service these compressors. So now I spoke a lot about the concept, but I also want to give you an idea on numbers. What does it mean? So we have one example of such an oil-free hydrogen compressor, which is running at 65 bar gauge. And with such an example, we achieved more than 27,000 operating hours. So this is actually over 3 years of uninterrupted service that we can achieve with such a system. Now with this, I'm already at the end of the presentation. I hope I was able to give you an insight on what it takes to maximize the uptime. I thank you for your attention, and I'm open to receive some questions now, or if you want to discuss further with us, we're just around the corner on booth E13. So also welcome to visit us there.
Thank you, Veronika. Are there questions from the audience? So one question that always fascinates me is a company with this name has to do compression in other fields. And there must be some interesting aspect of particularly hydrogen where you have to change your thinking processes. I would think of one thing, it's the purity of hydrogen you need for PEM cells, for example. There may be a pile of other issues. There may be the, what is it called, the Newton non-Joule effect, the way the gas performs when it's, you can explain that probably better than I can. It behaves differently than other traditional gases. So what are the issues specifically in dealing with compressing hydrogen relative to other gases? Is it really difficult?
Well, let's say the main challenge, we do hydrogen compression since many decades. It was used in refineries, in chemical plants, but always at the, let's say, at the moderate pressure levels. So what is new from the requirements from the market is really to achieve very high pressures. Mm-hmm. At the same time, oil-free. So actually, sealing is one of the big topics, how to provide sufficient sealing with such a light gas to have sufficient pressure buildup within the compressor. So that requires, on one hand, improvement, which we did on these kind of ring-type compressors. But then a second step, also we achieve, we are aiming at 900 bar, but with a completely different compressor. So actually what we took as a challenge for us, it started some years back, to develop a new compressor from scratch, which is used then for this ultra heavy duty refueling, 900 bars, this kind of application, which is a totally new service, let's say.
Mm-hmm. Among the new services we're waiting for, of course, are the pipelines that can deal with this gas, which is apparently more corrosive. Once you get the gas compressed, is there a network that actually is going to fulfill our needs 10 years down the road, or are we still in the start die Startlöcher in German? Are we still at the beginning?
There are big differences locally. I mean, the Netherlands is a nice example, which is quite advanced in examining the existing pipeline system and seeing where there are gaps to be closed or some valves and fittings to be replaced are fit for hydrogen. And then there are other continents or other countries also where basically the pipeline system is not ready for hydrogen. So that would be a huge effort to convert it. So I think we have to take the nearby solutions of infrastructure which are available. Sometimes it's just a small retrofit which is needed in some instruments, valves, etc., which we should definitely follow.
Well, for more questions and more details, I think we should join you at your booth, which is E13?
Yes.
Okay, E13. Veronika Schelling from Burckhardt Compression, thank you very much. Hope to see you back next year.
Thank you very much.
And thank you.